Hello everybody and welcome back. Hope you're all doing well. We're taking a look now at question number 7 on the grade 12 Manitoba Math Contest from the year 2016. How many of the first 2016 positive integers are divisible by none of 7, 9, and 32? Okay. So, divisible by none of them. Well, I think this question is just going to boil down to basic inclusion and exclusion principles. So our general strategy here is going to be find the number. We're not going to count how many aren't divisible by any of them. What we're going to do is we're going to count how many are divisible by at least one of those, and then everything that's left over, so 2016 minus that number, are the ones that are divisible by none of them. Okay, so how do we figure out how many of the first 2016 positive integers are divisible by at least one of them? Well, we're going to figure out how many are divisible by 7, then how many are divisible by 9, how many are divisible by 32, but there's some overlap. If something's divisible by 63, it's divisible by both 7 and 9, so we'll have to account for that as well. And so we're going to have to figure out how many are divisible by 63, how many are divisible by 7 times 32, how many are divisible by 9 times 32, and subtract those amounts off. But even that subtracts too much. We're going to have to add back in the ones that are divisible by both 7, 9, and 32. Okay, all of them. I mean, this has nothing to do with 2016. You can do this with up to any number, actually, and I'll show you how. But the basic idea is it's the principle of inclusion and exclusion, and it's sort of based off a Venn diagram here. So if we imagine a Venn diagram, the numbers in this circle divisible by 7, these ones 9, these ones 32, and the whole box, everything inside the box is one of the numbers we consider. Everything outside the circles is not divisible by any of them. We want to count this number. Well, to count this number, it's 2016 minus everything that's in the circles. Okay. Now, if I just add up the circle 7, the circle 9, and the circle 32, I have these overlaps. Well, each number in the overlaps is counted twice. I need to get rid of those, but the ones in the triple overlap are counted yet another time. So we have to be careful here. What are we to do? Well, we have to sort of explain what we're doing at each stage, so we'll write it out a bit. To find the number not divisible, we just take 2016 minus the number that are divisible by at least 1 of 7, 9, 32. Okay. So this is the number that are divisible by 7, plus the number that are divisible by 9, plus the number divisible by 32, so we're including everything, but there are some that we've included multiple times, so we've got to exclude overlaps, minus divisible by 7 and 9. And the nice thing here is they gave us numbers that are relatively prime, or co-prime, in that, you know, the smallest number that's divisible by both 7 and 9 is just 7 times 9. Whereas the smallest number that's divisible by 32 and 6 is not 32 times 6, it's actually 32 times 3. So I have to get rid of these overlaps, but then we get rid of each of these overlaps, and we've got some, so 9 and 32, minus the number that are divisible by 7 and 32, and then we have to add back in, we have to include again, so we've included, excluded, we include again, and I just want to double check. So if I were to call this A, B, C, D, E, F, G, right now we've got A plus B plus D plus E. That's the number divisible by 9 or by 7. B plus C plus E plus F. Really, I just want to keep track of how many E's. And then the number divisible by 32 would be D plus E plus F plus G. Now we just want A, B, C, D, E, and F at the end. Well, I've got too many b's, for example, so we got to subtract the overlap. Between 7 and 9 is b plus e. Between 9 and 32 is f plus e. Between 7 and 32 is d plus e. So, and then, so this cancels out with one of those. One of the d's cancels out, and one of the f's cancels out. And then an e cancels out here, an e cancels out here, and an e cancels out here, and we're left with a plus d plus b plus c plus f plus g, and so we need to include an e here. Okay. And my pen has stopped working. What's going on with that? There we go, plus e. All right. So we need to add in, just got to make sure these things, 7 and anything divisible by 7, 9, and 32. And you can even explain it with this Venn diagram if you really want to. Okay, but this is actually not so bad to do. So the number divisible by 7 plus number divisible by 9 plus number divisible by 32 minus the number divisible by, well, 7 and 9 together, 63, minus the number divisible by 9 and 32, which is, because I can't use a calculator, 288, minus the number divisible by 7 and 32, so 7 here, so 4, 1, 22, so minus the number divisible by 224, plus the number divisible by all of them, so we'll multiply 224 by 9, we get 36, carry the 3, 9, 8, so 9, 2, that's 18, plus 3 is 21, carry the 2, 9 times 2 is 18, plus 2 is 20, oh, 2016, nifty. Okay, so how many of the first, so the number of the first n integers divisible by n is just the floor function of n over n. Now actually, because we got 2016 and it's a multiple of 7, 9, and 32, we're going to get integers everywhere. We don't need to use this floor function here. But floor just means, if you've never seen floor before, it just means round down to the next, to the nearest integer. The greatest integer less than or equal to the current number you're looking at. So the floor of 3 is 3, and the floor of 4.2 is 4. It's the biggest integer that you can find that's less than or equal. And correspondingly, there's a ceiling function. We don't usually use that a whole lot, but so for example, how many numbers divisible by? How many of the first 7 numbers are divisible by 3? 7 over 3 is 2 1/3, which rounds down to 2. And yeah, there's 2 numbers of the first 7 that are divisible by 3, just 3 and 6. So this always works. You don't really need to justify it, but then our sum becomes 2016 over 7 plus 2016 over 9. And we're just going to have to do a whole bunch of divisions here. And we're going to get integers out. And actually, we're going to get some very nice numbers out. 2016, 288, I think that says. 2016 over 224 plus 2016 over 2016. Now, they're all integers. 2016 over 7, well, that's just 9 times 32. Didn't we work that out a little while ago? It's 288. 2016 over 9, that's going to be 32 times 7, because that's what's left over in terms of factors. So 224 and 63. And then when we subtract off 63, well, that's 2016 over 63, that's just 32. And then subtract off from 288, so 288 is 9 and 32, so what's going to be left? 7 and 9, and then add 1. And now I just need to add this all up. So we'll bring it over to the other side. 288 plus 224 plus 63 minus 32 minus 7 minus 9 plus 1. All right, get to adding. So this is 16, and this is 32, so this is minus 48 plus 1, so these two combine to be 64 minus 48, which is a difference of 16. And then 16 and 224 will add up to 240. So the 6's carries a 1 to 23, and then add on a 10. So 240 plus 288, 8 carry nothing, 12 carry a 1, 528. So 528 numbers are divisible by at least one of 7, 9, 32. Therefore, 2016 minus, and incidentally, that 2016 would be 2016 over 1. So, I mean, there's a connection there that we probably could have made with our earlier formula. Anyway, we just need 2016 minus 528 is the number not divisible by 7, 9, or even 32. 2016 minus 528. 16 minus 8 is 8. So get the 0 there. We get 1, 9, and then a 10. So there's another 8, and then so 1, 4, 8, 8. So 1,488 numbers between 1 and 2016 are not divisible by a 7, a 9, or even a 32. All right, so that wasn't so bad. Nice little question number 7. We got 3 more questions to go. I will see you guys in the next video for question number 8, although for a moment I'd like to stop and say thank you guys for watching, and for those of you who subscribe, thank you for letting me know about your support, and have yourselves a wonderful day. I'll see you for question 8 next time.